Hello there. Welcome to my presentation for the AI Assisted Coding Challenge. This project is a part of the CMPE 272 Enterprise Software Platform's final examination. The core objectives of this challenge was to securely transfer a 4 GB file over an untrusted network while strictly adhering to the CIAA security framework. Let's get started. To tackle this problem, I utilized a multi-stage AI orchestration strategy. I began by using Gemini Plus to develop a high-level plan. I provided Gemini with the task requirements and assessment checklist to discuss and refine our technical approaches. This collaboration resulted in a detailed specification document and an initial implementation prompt structured in stages. I then moved to Claude to execute the coding phase. By feeding Claude the specification and the stage prompt, I implemented the system piece by piece. After each stage, I performed a manual review and used Claude to address my technical concerns. Once the code was complete, I had the entire implementation reviewed by GitHub Copilot for further optimization. I then verified the logic through golden path and smoke testing. Finally, I had Claude generate the documentation for the first approach and repeated the entire process for the second approach while feeding the previous learnings back into the model. Let us start with approach A, MTLS streaming over TCP. This solution secures the 4 GB file transfer using mutual TLS 1.3 to ensure that only authenticated parties with valid certificates can establish a connection. You can find the full design details plus the CIAA mapping and smoke tests in the repository. To start, you need OpenSSL, Docker, and Docker Compose. So let me generate the certificates. Let me generate the test files. And let me build the Docker images. Let me start the containers. Now we will start the receiver. So it's now listening. We will start the sender. And I will start transferring the file. So the transfer is now complete, and we can verify that it was transferred successfully. Perfect. So the hash sum of the source file is the same with the transferred file. So approach A has other features, such as when a connection cannot be established by the sender, it will try again until the receiver is ready. When a connection is interrupted mid-transfer, the already transferred bytes will be deleted in the receiver. And when an attacker tries to connect with an untrusted certificate, it will be denied. So you can look at all of these in the repository and you can try them out. Let's move to approach B. So hybrid RSA and AES envelope. This solution uses an application layer encrypted envelope to protect data over plain TCP and includes native support for assumable transfers after connection drops. So please view the repository for more details on the cryptographic handshake and implementation steps. So I just moved to a browser and native terminal because Golang is taking a lot of CPU and memory. And okay, let's move on to the prerequisites are OpenSSL and Docker Compose, much like approach A. Let me generate the keys and also the test file, and let's build the Docker image. No, not that one. And let's start the containers. There you go. That was much faster. And let us start the receiver. Receiver is started. Let us start sending the file. Perfect. So transfer is complete. We just have to verify it that the files are the same. Perfect. So the SHASMs of the received and the transferred file are the same. Approach B also has additional features, like when it detects that data is corrupted, it will immediately stop the transfer and delete the already transferred files. Also, when an interruption happens in the middle of transfer, the sender and the receiver can resume from where it left off. And last but not the least, when an attacker tries to connect without valid credentials, it will be denied access. So that's it for my demo. This challenge demonstrated how leveraging different AI models for planning plus coding and review can lead to a robust and defensible security architecture. So thank you for watching my demo, and I hope you found this workflow insightful. Goodbye.